Now that we've practiced multiplying polynomials by a monomial, let's get into some more challenging multiplication. So for these notes, we'll look at multiplying binomials together. Now remember, a binomial is a two-term polynomial. So to multiply polynomials in general, but specifically binomials here today, we're going to use the distributive property and just make sure that each thing in the first polynomial gets multiplied by each thing in the second. So just like we've used the distributive property before, multiply through to each term in the second one, but do this for each term in the first one. And then check for like terms after multiplying to simplify the polynomial further. So let's try it. This is also known sometimes as the FOIL method. By the way, you'll hear FOIL, which stands for first, outer, inner, last. So that would be first, multiply the first two terms, the outer terms, the inner terms, and the last terms. But FOIL only works for binomials, and if you just remember the distributive property, this will work for any polynomial multiplied by any other polynomial. So let's try it here. So first we have x times x, that's x squared. X times 4, that's a positive, so plus 4x. 6 times x, that's a positive, or plus 6x. And then 6 times 4, and that's 24. So multiply each term in the first by each term in the second. We end up with 4 terms, which makes sense because 2 terms times 2 terms is 4 terms. But now we can simplify a little bit here by combining like terms. So x squared plus 10x plus 24 is our final polynomial. That is simplified there. We've multiplied through, combined like terms, and that's what we end up with. Example B, y times y, that's y squared. Y times 2 is a positive 2y. Negative 7 times y, make sure that negative stays there. That's a minus 7y. And then negative 7 times 2 is minus 14. Then combine those like terms, so y squared. 2 minus 7, that's negative 5y minus 14. Okay, example C, m times m, that's m squared. M times negative 1 is minus 1m, or minus m. Negative 5 times m is negative 5m. And negative 5 times negative 1 is positive 5. And then we can combine like terms, so m squared. Negative 1 minus 5 is negative 6m plus 5. Okay, let's move on. Example D, 8k times negative 2k, that's negative 16k squared, right? K times k is k squared. And then 8k times negative 1 is minus 8k. 3 times negative 2, negative 6k. And 3 times negative 1, minus 3. So let's combine that together. Negative 16k squared minus 14k, negative 8 minus 6 is negative 14, and then minus 3. There's the final polynomial. Example E, 2x, stuck on k's. 2x times x is 2x squared. 2x times 6y is plus 2 times 6 is 12, and then just xy, so 12xy. Negative y times x is negative xy, and then, so y times x, you can write yx or xy, but because we'll want to combine those like terms, if you always put them in alphabetical order, you won't miss that those are in fact like terms. If you had yx there, you might overlook that. So try to get in the habit of writing them in alphabetical order, and then they'll always match up. Okay, the negative y times 6 is negative 6y squared. So we'll combine these like terms. So we've got 2x squared plus 11xy minus 6y squared. Now for this one, whether you put the 6y squared or the negative 6y squared before the 11xy or not, all three of these terms have degree of 2. So The way I generally do it is put the x squared first because alphabetical order, and then this middle term has some x's in it, so it comes next, and then the y's at the end. Okay, last one. Negative 6x cubed times x squared is negative 6x to the fifth. 3 plus 2 is 5. Negative 6 times 3 is negative 18, and don't forget the x cubed. Negative x times x squared is negative x cubed, and negative x times 3 is negative 3x. And again, we do have some like terms to combine, so negative 6x to the fifth minus 19x cubed minus 3x. All right, so there's the basics there, some basic examples of multiplying binomials. Let's move on to some more special cases here. Now this is called the square of a binomial pattern, and because we are looking at a binomial squared, it's a little blurry here, but maybe you can see. So you can follow this pattern, but I would say just to be safe, you can always just write it out and do the work that way. But you can see when you have a plus b squared, you're going to end up with a squared plus 2ab plus b squared. And then a minus b squared, that middle term changes to a minus, but the rest is the same. But again, instead of trying to memorize that pattern, I would say just rewrite the problem as x plus 4 times x plus 4, or x minus 4 times x minus 4. What you don't want to do is just do like, oh, x squared and then plus 16 like that, because you do have these middle terms when you multiply it all out. So just be careful. I would say go ahead and rewrite that problem just so you don't miss those middle terms. So let's go ahead and multiply. X times x is x squared, x times 4 is 4x, 4 times x is 4x, and 4 times 4 is 16. And then those do combine to x squared plus 8x plus 16. And now trying the second one, x times x is x squared again. X times negative 4 is minus 4x. Same thing here, we get a negative 4x. And then negative 4 times negative 4 is positive 16. So they look pretty much the same, except this middle term is going to be a negative 8x plus 16. So slightly different result based on the sign in the binomial. But the important part is if you see a binomial squared, I would say safest bet is to just write that out and do the multiplication as normal. But you can remember the pattern plus 2ab. So you're going to multiply these numbers together and then double it. So 4x times 2 is 8x, or negative 4x times 2, negative 8x. Okay, so let's find that product here. Let's just do these. And again, to be safe, you can just write them out. X plus 7 times x plus 7, and then do that multiplication. So x times x is x squared. 7 times x is 7x. We get another 7x, and then a 49. And so those will combine in the middle. We have x squared plus 14x plus 49. Looking at example B. Again, if you're not sure, just write it out. 7y plus 2 times 7y plus 2. But to try the pattern, so first we take the first term and square it, 7y squared, and then again that's y, 7y times 7y right there. That's going to be 49y squared. And then we multiply the middle, the two terms together and double it. So 14y times 2, that's going to be 28y. And that's what we get by doing 2 times 7y and 7y times 2. Those are both 14y, and they're going to get added together anyway. And then the last term is just this number squared, so that's 2 times 2 is 4, and that's what we get right here. So it is just a shortcut to that multiplication, And the reason we can do that is because we know that we have the same numbers each time because it's 7y plus 2 all squared. And so that's why you can just multiply these together and double it instead of doing it and writing it all out like this. So let's try that again here. We have m minus 2 squared. So first of all, m times m is m squared. Negative 2 times m is negative 2m, but doubling that is going to be negative 4m. And then negative 2 squared is positive 4. But again, if doing that shortcut is confusing, just write out the problem. M minus 2 times m minus 2, and then multiply. So m times m, that's where we get the m squared. M times negative 2 is negative 2m. We have another one of those negative 2m's, and that's where we get the negative 4m from. And then negative 2 times negative 2 is positive 4. So again, if it helps, just write out and do the math. It's only one extra step to do it that way to be safe. But it is faster if you can remember the pattern. So on example D, 5y squared, that's 25y squared. 5y times negative 4 is negative 20y. We have two of those, so negative 40y. And then negative 4 squared is positive 16. So that's the binomial squared, of the square of a binomial pattern. But again, if it's confusing, if it feels like it's too much to remember, just write out the problem. You know, and this one would be 5y minus 4 times 5y minus 4. And then you'll definitely be safer and be able to write that all out and do the work as normal. It's not that much extra time. And that way you can be sure that you get the right answer at the end. In any case, remember, we're using the distributive property and then combining like terms after you multiply.